This is part 2 of the videos for Module 6 in Statway. In the first video, we saw that the z-value is the number of standard deviations from the mean, and it is x minus mu over sigma. We were looking at men's heights, and we saw that as we made the intervals smaller and smaller and smaller, we ended up with rectangles that seem to form a bell-shaped curve. And we could see right here that this is exactly what we have. When you have infinitesimally thin rectangles, this is the type of curve you get. The mean is always at the center of the curve. That's where the peak is. Now, this is called the normal distribution. In a normal distribution, the mean and the median are equal. Half of the values are below the mean, half of the values are above the mean. The normal curve is bell-shaped and symmetric with respect to the mean. So the shape on the left looks like the shape on the right. The area under the normal curve is 1. Remember, area represents probability. What is the sum of all probabilities? 1. And finally, normal curves extend endlessly in both directions. Now, they never actually touch the x-axis. Okay, so the probability is never exactly 0, but it certainly looks like it from the curve. But they're very, very close to the x-axis. All right, next, we're going to try to get a feel for how to look at normal distributions. Now, most data, just about all the data, is within 4 standard deviations of the mean. So using that knowledge, match the following graph with the appropriate mean 15 standard deviation 4. So first of all, graph A, this has a mean of 15. That's a candidate. Graph B, that is a mean of 15. Graph C, no, that's a mean of 13, so that's out. Graph D, that's a mean of 17, so that's out. Again, how do you know what the mean is? It's the data value at the peak. So we have a mean of 15 for graph A and for graph B. But we want the standard deviation to be 4. 4 standard deviations is 16. Now, we should have the curve approaching 0 when we're 4 standard deviations from the mean. So a mean of 15 minus 16 is negative 1. And the mean of 15 plus 16 is 31. Now, out of the choices A and B, which one of those two looks like the data could go to about minus 1 and 31? Well, the better choice is B. For A, it only looks like the data goes from 11 to 19, but we know it should be roughly minus 1 to 31. So which one of these is closer to fitting that requirement? It is graph B. The empirical rule is something that's very useful. In a normal distribution, notice I said about, not exactly, but roughly 68% of the data values lie within 1 standard deviation of the mean. Roughly 95% of the data values lies within 2 standard deviations of the mean. This one is going to be very useful for us. And finally, about 99.7% of the data values lie within 3 standard deviations of the mean. So right here, this is a little graph that shows you 1 standard deviation of the mean goes from mu minus sigma to mu plus sigma. That's 68%. Roughly, again, 68%. Now, 95%, that's within 2 standard deviations of the mean. Mu minus 2 standard deviations, 2 mu plus 2 standard deviations. Okay, we have said that a value in a normal distribution is unusual if it is more than 2 standard deviations from the mean. So now, a value is considered usual if it falls within roughly the 95% of most of the data. That's within 2 standard deviations of the mean. If it's more than 2 standard deviations from the mean, then it's considered unusual. Now that could be more than 2 standard deviations above the mean, more than 2 standard deviations below the mean. So let's get back to the example of men's height. Now for a man's height, the mean is 69, the standard deviation is 3. 2 standard deviations is 2 times 3, which is 6. So we can go down 6 inches from the mean of 69, or we could go above 6 inches from the mean. So, what range of heights belong to unusually tall men? Now, tall would be 2 standard deviations above the mean. 69 plus 6 is 75. So unusually tall would mean we're more than 2 standard deviations from the mean. So we're above 75 inches. Now let's look at this. Women's heights typically follow a distribution which is approximately normal. Now for women's height, the mean is 64, the standard deviation is 4. We want to find the probability that a randomly selected woman has a height between 52 and 68 inches. So what do we do there? We have to compute the z-values. Now for 52, how do we get a z-value? It's 52 minus the mean of 64 divided by the standard deviation of 4. That gives us a z-value of -3. Okay, and what about the z-value of 68? Well, you take the x value 68 minus the mean 64 over the standard deviation of 4. And that gives us a z-value of 1. So in a minute, I'm going to show you how to use the TI and come up with this probability. Now, what about the probability a randomly selected woman's height is less than 56 inches? Well, again, we're going to use the TI, but the TI doesn't know anything about the x values. It only knows about the z values. How do we get the z-value of -2? The data value 56 minus the mean 64 over standard deviation of 4. Okay, and if we wanted to get the probability a random woman's height is bigger than 60 inches, again, we need to find out the corresponding z-value. So it's the value of x, 60, minus the mean, 64, over the standard deviation of 4. So that's the probability z is bigger than -1. Alright, for the first one, let's look at, we want to get the probability z is between -3 and 1. So we need something called normal CDF. So what we're going to do is, you're going to hit the second button, then you're going to hit the VARS button. Now, we want the second option, right here, normal CDF. Enter. What is the smaller z-value? -3. Now for the negative, you use this value right here, not the subtraction sign, this value, -3. Go down. The upper value, what is the bigger z-value? 1. Keep hitting enter. And 0.839. Alright, and then we see that from the calculator, 0.8399, 0.8399. Now what about this next one? The probability z is less than -2. Okay, so the probability z is less than -2. Now over here, -2 is to the left of the mean 0. Less than -2 means we go to the left. Now, is there a left endpoint here, a lower value? No. The area keeps going to the left. Is there a right endpoint or an upper value? Yes, -2. So what we're going to do is, on our TI, we're going to come back, we're going to do second VARS, and again, normal CDF. Okay. Now for the lower, there was no lower endpoint. So what we're going to put in is negative, that's right here, 1. Now, E, how do we get the E? Second division sign, 9, 9. That tells the TI there is no left endpoint, there is no lower number. Okay, now negative 2, so we come down and we hit the negative sign here, negative 2. Okay. And we keep doing enter. And we get 0.0227. Okay. And that is close to what the Statway answer was. Okay. And now we know what that value is. Okay, now let's look at the last example. The probability z is greater than -1. Well, here's a picture from the normal distribution. Greater than -1, that's the area to the right of -1. So notice there is a left endpoint, but there is no right endpoint. It keeps going, going, going. So how do we show that with our calculator? Okay, so again, we're going to do second. Vars, normal CDF, enter. Now for the lower end point, there was one, -1. So again, -1. The upper end point, there was none. It kept going, going, going to the right. We signify that to the TI with a 1E99, 1. Now again, the way to get the E, the second button and the division sign. 9, 9. Enter. And we get 0.84, which is what we have right there. Okay, now sometimes we know the area, but we want to find the associated z-value. That's called the critical value. Now for our TI, if we want to know the probability, we know the probability to the right of a z-value is 0.06. We want to find out what is that z-value. Well, for our TI, it doesn't know about area to the right of the z-value. It knows about area to the left of the z-value. So if the area to the right is 0.06, the area to the left is 0.94. Remember, the total area is 1. 1 minus 0.06 is 0.94. So we come to our TI. Now we're going to do this. Second, and we're going to do vars again. But now we're going to move down and we're going to go to option 3, inverse norm. What is the area to the left of the z-value we want to find? It's not the 0.06. It's 1 minus 0.06, which is 0.94. Keep doing enter. And we get a z-value of 1.55. But we really want to know what the x value is. So how do we get the x value? The formula is the x value is the mean plus, we know the x value is the mean plus z times the standard deviation. So in this case, we're still looking at women's heights. So the x value is 64, the mean, plus we just got the z value, 1.55, times the standard deviation 4. So for the tallest 6% of women's heights, again, tallest 6%, let's come back over here. What is the woman's height? It is 70.2 inches.